Hello everyone, welcome back. Today we're going to be starting our very first video on the AP Chemistry series. We're going to be going over Lewis diagrams and resonance structures. This is a pretty big topic on AP Chemistry since it will allow us to analyze molecular polarity as well as bond geometry. So we could determine the shape of the molecule, either if it, for example, it was bent, tetrahedral, trigonal planar, and so on. But we will worry about those topics later on. All we want to focus on right now is just how to draw Lewis diagrams and how to identify resonance structures. So with that being said, let's get into it. Alright, so the very first slide that I have here is what is the general format of Lewis diagrams. So on the left side here, the left picture is boron trifluoride. So of course, essentially we have one boron atom and also you can see here that we have 3 bonds between the 3 fluorine atoms. Now, 2 takeaways I want us to consider from this image is, well, you might be asking, why is fluorine not in this central spot here? Why is boron there? Well, a general rule of thumb with Lewis diagrams is that the atom that is central is always the one that is the least electronegative. So again, keep in mind that the atom that is the least electronegative goes into the central spot. And also, another big aspect here is that you can see the diagram is symmetrical, right? If we have one boron atom here and then 3 fluorine atoms branching off, the overall shape is symmetrical compared to, for example, if we had boron here or boron there, one fluorine atom here, just on the side, it would just make this shape look kind of weird and not nice looking, essentially. So, 2 big takeaways. We want to consider the central atom to be the one that is the least electronegative, and that we want symmetry. Symmetry is very, very important. For example, in this picture here I also included, you see here that carbon is least electronegative than oxygen, right? But, well, hydrogen would be actually the least electronegative atom, right? But again, symmetry. Carbon and oxygen, yes, carbon is less electronegative, but we also put carbon in the central spot here compared to hydrogen because of symmetry, right? Because we have 2 hydrogen atoms compared to 1 carbon. So that is the general format of Lewis diagrams. Now, another big aspect, and you saw in my title slide, is we're going to be talking about resonance structures here. And what are they? So essentially what we do with resonance structures is we denote them, especially when we have molecules that have double or triple bonds. So that is a big aspect there, double or triple bonds. And the idea here is that we place a double or triple bond between one atom, the central atom primarily, and another outer atom, and we can do this between several of the outer atoms and the central atom, and this would result in a valid Lewis diagram. So let's take a look at this diagram down here. So for example, in this first one we see sulfur double bonding between this oxygen and this oxygen, right? Well, that would be the same valid diagram if we had this sulfur double bonding between this oxygen and this oxygen. Same with this one. You see here that the double bond is kind of switched around, right? Because this one here was double bonding between this guy and this guy. But in this diagram, it's between this one, that's correct, it's the same one, but now it's between the opposite side. It's with this oxygen. Now, again, same oxygen atom here, between these 2 guys, these 2 diagrams, but now the new oxygen atom that is double bonded is between this one. So again, you can see that the double bonds are shifted around in the diagram. It's not just, for example, one spot, one valid spot that the double bond can be placed between the central and the oxygen atom. In fact, it can go around. It can be shifted around to another oxygen atom. As you can see here, even this oxygen atom is double bonded, right? And then we can have a double bond between this oxygen, all the oxygens in this diagram are double bonded, but in just different spots in different places. So that is the general idea of resonance structures. We'll take a look at how to create them in an example, and I'll break down, of course, how to identify again when we have a resonance structure. Now, what about diagrams with charges? So, for example, in this molecule here, CHO, with a 1- charge, after we draw the Lewis diagram, you can see here that we put brackets around it, right? And then after we put brackets around the CHO molecule, we put the charge on the top right, so right there. And then this guy happens to have a resonance structure, lucky for us. So this CHO molecule has a resonance structure, and the same thing we do there is, of course, we draw the brackets around it, and the -1 charge will go to the right-hand side as well, top right-hand side. Again, with the resonance structures, we draw that, and then, of course, if a molecule has a charge, we just write that on the top right-hand corner of the bracket. Now we are on to our example. So the example that I want to go over is going to be carbonate, just the carbonate ion. So the carbonate ion is CO3 with a 2- charge. So that is carbonate. Now I'm going to walk you guys through, of course, how we can identify or really create the Lewis diagram from scratch, and on a step-by-step approach. So first thing I want to do, and first thing I want to ask you, which atom is going to be our central atom? So which atom is going to be our central atom? If you want to pause this video, think about it, do so, but I'm going to be saying this right now. It's going to be carbon. Carbon is going to be our central atom. Draw it in the center there. The reason why, if we take a look at this periodic table for reference, the first thing I mentioned, if you remember, was we want to put the least electronegative atom as our central atom, right? The general periodic trend for atoms essentially is that when we move towards the right, the more electronegative atoms become. So oxygen is more to the right of carbon, right? Oxygen is more to the right, so carbon would be less electronegative than oxygen. So that's one reason why we would put carbon as our central atom. But another reason why is that we have 3 oxygen atoms and only 1 carbon. So based on symmetry, carbon would ideally be our central atom, because that would make for a nice Lewis diagram, right? Having 3 oxygen atoms branching off from 1 carbon. So 2 reasons there. If you said one of them, you are right. But again, 2 reasons there, just to keep in mind that carbon is our central because it is less electronegative, and also based on symmetry. Now let's just ideally draw what it would look like, what we think it would look like right now. C and 1 oxygen, C and 1 oxygen, and then C and another one there. Okay, this is a rough draft, essentially what I would like to call it, of our Lewis diagram. But of course it's not complete. We're nowhere near done with what we have right now. But the next step we need to do is that we need to find the number of valence electrons in the molecule. So how we do that is that we take a look at each atom, right? So we have 1 carbon, we have 3 oxygens, right? So let's take a look at our carbon. Let's find how many valence electrons carbon has. So it's in group 14, right? And I think that's a little bit too small. Sorry about that. And let me draw oxygen as well here. Carbon is in group 14. Oxygen is in group 16. So how many valence electrons do they have? There's a trick here. And the way I understand how many valence electrons there are is by looking at the the second digit value. Forget about the 1. We don't take a look at the 1. So simply just let me erase that actually. So we forget about the 1s, okay? The number of valence electrons that carbon would have would be 4. And 6 for oxygen. So again, what I did here was that I took a look at the top number, right, of the group, and then I ignored the 1. All we take a look at is just the second digit value, and that is your number of valence electrons. So carbon again has 4, oxygen has 6. But again, we need to take a look at the molecule here. We have 1 carbon. 1C equals 4 valence electrons. 3 oxygens. 6 times 3 equals 18 valence electrons. Okay, so we add the 18 plus the 4. So let me just bring this down here. 18 plus 4 is 22 valence electrons. Hopefully I did not make a mistake on that. And then, okay, 22 valence electrons, but, big but there. We need to take a look at the charge. There is a 2 minus charge on carbon 8. And what that means is that ideally, if you remember, that when we have a negative charge on an atom, essentially this is a molecule anyways, regardless, when we have a negative charge, that means an atom gains an electron, right? It adds an electron. So in this case, since it is a 2 minus charge, all we have to do is that we have to add the 2 to the 22. So 22 plus 2 is equal to a total of 24 valence electrons. That's it. We have our total valence electrons is 24. So again, after we added all the valence electrons of each atom in this molecule, and after we added the charge value, we got our total number of valence electrons, which was 24. Okay, 2 steps done. We're almost there. Now all we need to do is we need to just see the organization of the bonds. And one thing I should have mentioned this earlier, in fact, in my slideshow, was that each bonding pair, so for example, this carbon bonded to this oxygen, represents 2 valence electrons. So 2, 4, 6. So far we have 2, 4, 6 valence electrons, but we have 24. We need 24, right? So also another another key aspect to consider here is that when we draw Lewis diagrams and the bonding pairs, we also draw what are called lone pairs. And we draw these lone pairs so that the atom can have a full octet, meaning that the atom has 8 valence electrons. So let's take a look at carbon, for example. We have 2, 4, 6, so it needs 2 more valence electrons, right, to become 8. So 2, 4, 6, we add 1 electron there. That's our lone pair for carbon. So 2, 4, 6, 8, we have our full octet for carbon. This oxygen only has 2, right? Because it has only one bonding pair, one bonding between the carbon. That's only 2 valence electrons. So it needs 1, 2, 3, 4, 5, 6 electrons. So 2, 4, 6, 8. Oxygen is fine here. Same thing with this one. We need 2, 4, 6. This oxygen is good. Then we need 2, 4, 6, 8. This oxygen is good. Now, does that mean we're done? Does that mean we have the 24? Well, now we need to count everything up. So we see here again 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So we have 2 more electrons than we're supposed to have. We have 26 compared to 24. How do we fix this? That's where the solution of the multiple bonds in the Lewis diagram comes in. So what I mean is, what we need to do here, just remove this one. If I remove this carbon, this bond between this carbon and oxygen, I also need to remove the lone pairs here and add a double bond. Perfect. So 2, 4, 6, 8, 2, 4, 2, 4, 6, 8. I also need to remove this guy, this lone pair in this carbon. Okay, so let's see now. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. There we go. We got our 24 valence electrons, thankfully. That was a pretty long process there. So we have our basic Lewis diagram for carbonate, which is excellent. But again, we are not necessarily done. This is an atom or molecule that has a charge. It's a 2- charge. If you remember, we need to add brackets. We need to add the brackets around this Lewis diagram, indicated by its charge on the top right-hand corner. Also, another thing you can see is that this carbon and this oxygen is double bonded, right? Do you think we can make a double bond between this carbon and this oxygen? And the same thing goes for this carbon and this oxygen? Well, we can, because again, these atoms are symmetrical, right? They're all oxygen. They're all oxygen bonded to a carbon. So since we did a double bond between this carbon and this oxygen atom, we can do the same thing for each other oxygen atom. And that, of course, if you guessed it, is resonance structure. So we can draw a double bond between this carbon and this oxygen, which was on the left-hand side. 2, 4, 6, 8, 2, 4, 6, 2, 4. And of course, don't forget the brackets with a 2- charge. We have another one, another resonance structure with a double bond between this oxygen, which was the other one we were missing. So C and then this O. Here we go. Bracket with the 2- charge. There we go. We are all finished drawing not only the Lewis diagrams, but also the resonance structures of the carbonate ion. Pretty long process there, but really the step-by-step approach I wanted you guys to see from my perspective, how I did it, again, was to look at first, take a look at the number of valence electrons in each atom. Carbon was 4, oxygen was 6. How did I do that? I founded the group number, then I just ignored the 1. All we took a look at was the second digit value. Carbon was 4 again, oxygen was 6. Then I added each of the number of atoms, right? Oxygen was 3, so I took the 6 valence electrons times 3 was 18. And we have 1 carbon, so all we needed to do was to add the 18 with the 4 to get 22. After that, I took the charge value. If it has a charge, depending on the charge, of course, if it's a minus charge, we add the number to the valence electrons. But I should have mentioned this earlier as well. But if this was plus 2, so for example, in this case, if it was a plus 2 charge, we would actually subtract 2. So instead of being 24, if this was plus 2, it would be 20. So just keep that in mind. Depending on the charge, if it does have a charge, if it's a minus, we add it. If it's an addition, we subtract. But in this case, of course, for carbonate, it was a minus 2, so we added the 2 to the 22, which gave us 24 valence electrons in total. And then, depending on the, of course, bond structure, if we needed to, we could have a double bond or even a triple bond. And if the atoms are symmetrical, if we could add, for example, a double bond between another atom of the same type, if this was an oxygen, this was oxygen, we could have done the same double bond between this guy and this guy as well as this guy, right? And that's what we did. We created 3 different resonance structures of the same or the basic Lewis diagram. And that pretty much completed, of course, all of the process there. But I know I went over a lot. I hope you guys, though, got a better understanding of how to construct a Lewis diagram and some of the resonance structures. And I hope you found this video helpful. Thank you guys so much for watching. But if you guys have any questions, feel free to let me know. Of course, reach out to me. Do not hesitate. And with that being said, thank you so much for watching again. I will see you in the next one.